January 28, 1986. Tuesday morning, Florida. The sun had just risen at Kennedy Space Center, but it hadn't warmed the air. Kennedy is normally hot, humid, but that morning was different. Thermometers showed 36 degrees Fahrenheit, 2 degrees Celsius. Unusually cold for Florida. On the launch pad, Space Shuttle Challenger was waiting. Its white body gleamed in the sunlight, the giant orange external fuel tank in the middle, 2 white solid rocket boosters on the sides. Elegant, powerful, looking like a symbol of the future. But something on the pad looked strange. Icicles, ice hanging from metal. In Florida. Unusual. Inside the shuttle, 7 people were sitting. 7 astronauts, in white spacesuits at their stations, ready. They were excited, not afraid. This was a routine mission. They'd launch a satellite, conduct science experiments. But one thing made this mission special. One of them wasn't an astronaut. She was a teacher, Christa McAuliffe, 37 years old, a high school teacher from New Hampshire. She had 2 children, Greg and Scott, and today she was going to space. The first civilian, teacher in space program. 11,000 teachers had applied, she was chosen. She'd teach from space, show students Earth, show them weightlessness. Space wasn't just for astronauts anymore. Teachers could go too. Anyone could go. America was watching with excitement. Schools had brought televisions into classrooms. Millions of children sat in front of screens. A teacher was going to space, someone like their teachers. An ordinary person. It meant anything was possible. At Kennedy Space Center's viewing area, families were waiting. Christa's parents were there, Grace and Ed Corrigan. Watching with excitement, pride, a little anxiety. Their daughter was going to space. The countdown began. Voices from mission control. T-minus 10 seconds. 9, 8, 7. Main engines ignited. 3 hydrogen engines. The shuttle vibrated on the pad, held. Then the solid rocket boosters ignited. Massive white smoke. Thunder. Light. Liftoff. We have liftoff of Challenger. The shuttle slowly began to rise. Left the pad, started climbing toward the sky. Slowly at first, then faster, faster. The crew was pressed into their seats by pressure. 3 Gs, heavy, but beautiful, thrilling. Outside, people watched, families in the viewing area, Christa's parents, clapping, crying, smiling. Thousands had gathered around Kennedy Space Center. Beaches were full, roads were full, everyone looking up. On television, millions watched, children in classrooms watched. Teachers said, "Look, a teacher in space." Cameras tracked, white smoke trail. Against the blue sky, beautiful. Perfect image. Mission control, roll program. The shuttle slowly rolled, entered the correct orientation. Challenger, go with throttle up. Engine power increased. Everything looked perfect. But it wasn't. If you watch slow-motion video, you see something at ignition. From the bottom of the right solid rocket booster, from an O-ring joint, a black puff of smoke. Doesn't last even a second. But it's there. Hot gas leaking. O-ring failed. A few seconds later, the smoke stops. Good? No. Aluminum oxide, residue from burned aluminum, formed a temporary seal, plugged it. But temporary. As pressure increased with vibrations, this seal would break. 30 seconds passed. 40. 50. Inside, the crew was comfortable. Everything normal. Sounds, vibrations, speed, just like in training, no problem. But outside, at that O-ring area, something was happening. 58 seconds. Flame became visible. Small, but there. Hot gas now continuously leaking from the right booster. Like a flame. 64 seconds. The flame grew. Now a long flame. And it was hitting the external fuel tank, the big orange tank in the middle of the shuttle. Hundreds of tons of liquid hydrogen and liquid oxygen inside. 72 seconds. The flame began melting the tank's structure, the H-bracket support strut. The tank was held to the shuttle by these connections. When the strut melted, the tank shifted. The crew still didn't know. Sensors hadn't alarmed yet. 73 seconds. 7 people were inside Challenger that morning. 7 different lives, 7 different stories. But they all shared one goal: to touch the stars. Francis Richard Scobie, but everyone called him Dick. He was 46. The shuttle's commander. He'd spent years as an Air Force pilot, flew combat missions in Vietnam. Calm, experienced, a reliable leader. This was his second spaceflight. When he returned from his first flight, he'd been so happy to spend time with his family. His wife, June, and 2 children. He'd told them, "I'll be back in a few days, don't worry." Space had become routine for him. Not dangerous, just his job. Michael J. Smith was 40. Challenger's pilot. He was a Navy pilot, had learned to take off from aircraft carriers, one of the world's most difficult piloting jobs. But this was his first spaceflight. He'd dreamed of this for years. Applied to NASA, got accepted, trained, waited, and finally his turn came. In an interview before launch, he'd said with a smile, "This is the best job I've ever had." He was excited, happy like a child. Ronald McNair was 35, mission specialist, physicist, brilliant scientist. Had his PhD from MIT, but he wasn't just a scientist. He played saxophone, was a black belt in karate. This was his second spaceflight. On his first flight, he'd planned to play saxophone in space, but hadn't found time. He'd promised to definitely play this time. His wife Cheryl and 2 young children. He'd told them, "I'll send you greetings from space." Ellison Onizuka was 39, mission specialist, Air Force, Japanese-American. Grew up in Hawaii. Started his career as a space engineer, then became an astronaut. He was a source of pride for his family. This was his second spaceflight. After his first flight, he'd returned to Hawaii, given talks to children at schools. "Follow your dreams," he'd told them. "Nothing is impossible." Judith Resnick was 36, mission specialist, electrical engineer, brilliant, determined, tenacious woman. She was NASA's second female astronaut. This was her second spaceflight. On her first flight, she was on Discovery, almost became the first American woman to walk in space. She loved space. "Looking at Earth is incredible," she'd said. "Everything looks so small, problems seem so insignificant." Gregory Jarvis was 41, payload specialist, engineer at Hughes Aircraft. He'd waited years to go to space, been assigned to other missions, but then replaced due to other astronauts' illness or changes. He'd thought his turn would never come. But finally it did. It would be his first and last spaceflight. And Sharon Christa McAuliffe. Everyone called her Christa. 37 years old, high school teacher, taught social studies at Concord High School in New Hampshire. Married, her husband Stephen was a lawyer. 2 children, 9-year-old Scott and 6-year-old Caroline. A normal family, a normal life. But Christa had gotten an extraordinary opportunity. NASA had started the Teacher in Space program, the idea of opening space to the public. Not just military pilots, ordinary people could go too. First, a teacher. 11,000 teachers applied. Christa was chosen. Why? Her application video was amazing. "I touch the future," she'd said. "I teach, and now I'll teach from space." NASA loved her, the media loved her, America loved her. She was cheerful, excited, warm. She didn't have the military bearing of astronauts. She was a normal person, and that made her special. She'd teach 2 lessons from space. First, the ultimate field trip. She'd explain space, introduce the shuttle, show daily life. Second, where we've been, where we're going. She'd talk about the history and future of the space program. Simple lessons, but important, because millions of children would watch. Space would become real for them. If a teacher was in space, maybe one day they could go too. That morning, January 28th, as Christa boarded the shuttle, she'd waved to cameras, smiling. Her parents were waiting in the viewing area. Her children would watch on TV. 7 people, 7 dreams, 7 families, all would be gone in a few minutes. The space shuttle idea was born in the 1970s. The Apollo program had gone to the moon, succeeded, but was too expensive. Every rocket was single-use. Went to space once, fell into the ocean, done. Not sustainable. New idea, reusable spacecraft. Would take off like a plane, go to space, then land like a plane. It had wings, would land on runways. Then would be repaired, refueled, fly again. Again, again, again. Dozens, maybe hundreds of flights. Space wouldn't be a one-time adventure anymore, but routine work. NASA's promise was big. Shuttle would fly once a week. 50 flights a year. Launch satellites, build space stations, do science, and very safe. Because it would be tested repeatedly, checked after every flight. Not single-use like Apollo, a continuously evolving, continuously improving system. And most importantly, not just for astronauts. Engineers would go, scientists would go, teachers would go, journalists would go. Space would be democratized. In 1981, the first flight happened. Columbia. 2 astronauts, John Young and Robert Crippen. A perfect flight. Took off, entered orbit, stayed 2 days, returned, landed at Edwards Air Force Base. Success. America watched joyfully. Then more flights came. 1982, 1983, 1984, 1985. Satellite launches, science experiments, spacewalks. Everything was going perfectly. There were a few small problems, of course. One astronaut almost got lost in space. Some heat tiles fell off. Erosion was seen on O-rings. But these were small things. Not dangerous. Tolerable. Challenger entered service in 1983. Second shuttle after Columbia. Made beautiful flights. 9 flights by the end of 1985. No major problems. STS-51L mission was Challenger's 10th flight. Routine, simple. They'd launch a satellite, observe Halley's Comet, Christa would teach her lessons. 7 days long, an easy mission. Or so they thought. Because space was actually dangerous. Rockets were actually dangerous. Every launch burned hundreds of tons of explosives. If something went wrong, the consequences would be catastrophic. But NASA had forgotten this. After 24 successful missions, space had become routine. Not dangerous, just work. That thinking was deadly. January 27, 1986, Monday. Challenger's launch was planned. But in the afternoon, a decision was made. Postponement. Weather was getting worse. Wind was too strong, not safe. New date, January 28, Tuesday morning. But there was a problem. Weather forecast showed a cold front coming. Unusually cold for Florida. Maybe dropping to 29 degrees Fahrenheit overnight, -2 Celsius. At Morton Thiokol, engineers got worried. Morton Thiokol was the company that made the solid rocket boosters. 2 giant white rockets on the shuttle's 2 sides. Each consisted of 5 segments. Segments connected to each other, and at the connection points were O-rings. O-rings were rubber seals. Their job was simple: provide sealing between segments. When the rockets ignited, there'd be very high pressure inside, hot gas. O-rings prevented this gas from leaking out. Very important job. Because if hot gas leaked, it could damage external structures, could damage the fuel tank, could be catastrophic. Bob Ebeling and Roger Boisjoly were 2 chief engineers at Morton Thiokol. They'd studied O-rings for years. And they knew something. Rubber gets hard in cold, loses elasticity, doesn't seal properly. They looked at past flights. In shuttle launches in cold weather, O-ring erosion was greater. Hot gas had leaked a little. There were burn marks on O-rings. They'd been lucky so far, not too much leakage. But luck doesn't last forever. January 27th evening, a teleconference was held. NASA, Morton Thiokol, Marshall Space Flight Center managers. Topic: launch approval. Engineers made their presentation, showed graphs, presented data. Conclusion: do not launch below 53 degrees Fahrenheit. O-rings may not provide reliable sealing. 53 degrees Fahrenheit, about 12 degrees Celsius. And the predicted temperature for January 28th morning: 29 degrees Fahrenheit, -2 Celsius. Much colder. NASA managers asked questions. Do you have definitive proof? Will it definitely fail below 53 degrees? Engineers: no definitive proof, but risk is very high. Data shows more erosion in cold. We don't know what happens in colder temperatures. We haven't tested it. NASA: so you can't say it's definitely unsafe? Engineers, we can't say you'll definitely die, but there's high risk. Don't launch. But this wasn't enough for NASA, because there was schedule pressure. Challenger's launch had been postponed several times. Media was criticizing. NASA can't launch on time, they were saying. Congress was starting to question the budget, and President Reagan was giving his State of the Union speech that evening. He was planning to mention Christa McAuliffe. Right now, a teacher is in space, he'd say live on air. For this to happen, the launch needed to be that day. Schedule was important, politics were important, image was important. Morton Thiokol management talked with the engineers. Take off your engineering hat, put on your management hat, they said. Meaning don't think technically, think politically. Think about the company's interests. Make NASA happy. Finally, Morton Thiokol management made their decision. We approve the launch. Engineers objected. Roger Boisjoly tried one last time. This is very dangerous. Please listen. Risk is too high. But management had decided. Teleconference ended. Launch approved. Bob Ebeling called his wife while driving home. His voice was shaking. Tomorrow Challenger will explode, he said. 7 people will die, and I'll know. I couldn't stop them. His wife tried to calm him. You did what you could. What more can you do? Bob didn't know, but he had a terrible feeling inside. He knew something very bad was going to happen. January 28th morning. Sun rose. Temperature 36 degrees Fahrenheit, 2 degrees Celsius. The coldest launch ever. Icicles were on the launch pad. Workers tried to break them, but ice was still on the metal. The O-rings were underground, in invisible places. They were even colder. Engineers waited by their televisions, frightened, helpless. They could only watch. January 28, 1986, Tuesday. 11:38 a.m. launch time. The crew had boarded the shuttle hours earlier, got up early in the morning and prepared, put on white spacesuits, got their equipment, got on the bus to the launch pad, took the elevator up, walked past the shuttle, so big, so white, so powerful. Went inside. Through a narrow entrance, one by one, seats were positioned lying back, they squeezed in. Very cramped, very tight. Straps fastened, helmets with headphones on, lying on their backs. The shuttle stood upright, they lay on their backs, looking at the sky. Christa McAuliffe looked out the window. Blue sky. Clouds. Beautiful. Thought of her parents. They're watching. Thought of her children. Watching on TV. Thought of her students. Waiting excitedly. She smiled. Mission Control was doing checks, hundreds of checks, every system, every sensor, fuel, electricity, computers, everything green, everything ready. Countdown began. T-minus 10 minutes. T-minus 5 minutes. T-minus 2 minutes. The crew was silent, waiting, adrenaline rising, but trying to stay calm. That's what they'd trained for, professionals. T-minus 1 minute. T-minus 30 seconds. T-minus 10 seconds. The countdown. Everyone knows it. Children in school were repeating it. 10, 9, 8, 7, 6. Main engines ignited. 3 hydrogen/oxygen engines. The shuttle vibrated on the pad, held on. The sound was incredible. Their chests pounded from vibration. 3, 2, 1, 0. Solid rocket boosters ignited. 2 giant rockets. Massive flame, massive smoke. Liftoff. We have liftoff of Challenger. The shuttle slowly began to rise. Left the pad, started climbing toward the sky. Slow at first, then faster, faster. The crew was pressed into their seats by pressure. 3 Gs, heavy, but beautiful, thrilling. Outside, people watched. Families in the viewing area, Christa's parents, clapping, crying, smiling. Thousands had gathered around Kennedy Space Center, beaches full, roads full, everyone looking up. On television, millions watched. Children in classrooms watched. Teachers said, "There, a teacher in space." Cameras tracked. White smoke trail. Against blue sky, beautiful, perfect image. Mission Control, roll program. The shuttle slowly rolled, entered the correct direction. Challenger, go with throttle up. Engine power increased. Everything looked perfect. But it wasn't. If you look at slow-motion video, at ignition something is visible. From the bottom of the right solid rocket booster, from the O-ring joint, a black puff of smoke. Doesn't last even a second. But it's there, hot gas leaking. O-ring failed. A few seconds later, smoke stops. Good? No. Aluminum oxide, residue from burned aluminum, formed a temporary seal. Plugged it, but temporary. As pressure increased, with vibrations, this seal would dissolve. 30 seconds passed. 40. 50. Inside, the crew was comfortable. Everything normal. Sounds, vibrations, speed, like in training. No problem. But outside, at that O-ring area, something was happening. 58 seconds. Flame became visible. Small but there. Hot gas now continuously leaking from the right booster, like a flame. 64 seconds. The flame grew, now a long flame, and hitting the external fuel tank. The big orange tank in the shuttle's middle, hundreds of tons of liquid hydrogen and liquid oxygen inside. 72 seconds. The flame began melting the tank's structure, the H-bracket support strut. The tank was held to the shuttle by these connections. When the strut melted, the tank shifted. The crew still didn't know. Sensors hadn't alarmed yet. 73 seconds. 73 seconds. After liftoff. Altitude, 46,000 feet, about 14 kilometers. Speed, Mach 1.92, almost twice the speed of sound. The external fuel tank structure completely failed. The upper part separated. The liquid hydrogen and liquid oxygen inside mixed. Contact occurred, and then instantly explosion. Hundreds of tons of liquid hydrogen and oxygen instantly ignited. Chemical reaction, massive fireball, orange, white, bright. Suddenly a huge light in the sky. The shuttle disintegrated. Not exactly an explosion, rapid disassembly is the more accurate technical term, but same result, the shuttle as a whole ceased to exist. Broke into pieces. The white smoke trail suddenly split into a Y shape. Two solid rocket boosters veered off in different directions, still burning, still powerful, out of control, flying wildly, pieces of the shuttle scattered everywhere. Wings, fuselage, engine parts, heat tiles, everything, rain of debris. At mission control, screens suddenly changed, telemetry cut off, no data. Sensors silent, controllers looked at their screens. What's happening? Tried to understand, then the cameras on screens showed it. The fireball in the sky. Silence, nobody was talking, shock, disbelief. Then came the voice of the NASA television commentator. Live on air, millions listening, his voice shaking, hesitant, shocked. Flight controllers here looking very carefully at the situation. Obviously, a major malfunction. A major malfunction. What an inadequate phrase. 7 people had just died. On television people saw it. The fireball, the Y-shaped smoke trails, falling debris, they didn't understand. Was this an explosion? Separation? Where's the shuttle? In the viewing area, Christa's parents looked up, mouths open, faces showing disbelief. Their daughter. Where? People around them were silent. Then screams, crying. Fear. In classrooms, teachers turned off televisions. Children asked what happened. Teachers didn't know what to say. The 2 solid rocket boosters were still flying, out of control, dangerous. The Air Force range safety officer sent the remote destruct command. 2 more explosions, 2 rockets disintegrated. For safety, debris started falling into the Atlantic Ocean, pieces everywhere, wide area. At mission control, everyone was in shock. Phones started ringing, senior managers calling. What happened? Explain. But nobody knew. Not yet. All they knew, Challenger was gone, 7 astronauts were gone, and the world had watched it live. At the moment of explosion, there was a question, one nobody dared ask. Did they die instantly? The answer is complex and very tragic. At the moment of explosion, the shuttle disintegrated. But the crew cabin, the front part of the shuttle, didn't completely disintegrate. Largely remained intact, with the 7 astronauts inside. The cabin was subjected to violent forces, over 20 Gs, very violent, but survivable, especially if sitting, strapped in. And then the cabin began free fall. From 46,000 feet altitude, 14 kilometers, toward the ocean. The fall lasted 2 minutes 45 seconds. Investigation later revealed a horrific detail. 3 personal egress air packs, PEEPs, had been activated. What's a PEEP? Emergency air mask. If cabin air runs out, if pressure is lost, astronauts use this. But it doesn't open automatically. Has to be opened manually. Astronaut has to reach out, pull a lever. Pilot Michael Smith's PEAP was active, and 2 mission specialists' PEAPs were active. 3 people. What does this mean? It means, after the explosion, while the cabin was falling, at least 3 astronauts were conscious. They couldn't breathe, cabin pressure was lost. At that altitude, there's no air. But they were still conscious, and managed to activate their PEAPs. Think about it, the cabin falling, out of control, maybe spinning. The astronauts inside trying to understand what happened, can't breathe, activating their PEAPs, and they know they're falling, ocean approaching. 2 minutes 45 seconds, a very long time. While falling, knowing. The cabin hit the ocean at over 200 miles per hour, over 330 kilometers per hour. At impact, nobody could survive. Instant death. But before impact, they were conscious. NASA never officially confirmed this, for the family's sensitivity. In the public report, it only said PEEPs were found, some were active. Didn't give details, but the truth was clear. At least 3 astronauts, maybe more, were conscious after the explosion, experienced the fall. What did Commander Dick Scobie think? Did he try to save his crew? How did he feel when he realized nothing could be done? What did Michael Smith think on his first flight while realizing his dream? What did Christa McAuliffe think, teacher, mother? Did she remember her children? We don't know. We'll never know. But we know what they knew, that they were falling, that the end was approaching, and that they could do nothing, maybe for minutes, maybe conscious for only seconds during the fall. But it was enough. A horrific end. This is the most tragic detail. They didn't die instantly, they knew. Immediately after the explosion, Coast Guard and Navy began search operations. In the Atlantic Ocean, over a wide area, there was debris. Pieces floating on the surface, some had sunk. Ships came, divers went down, helicopters flew. Debris was collected. Where was the crew cabin, the people inside? They didn't know. Days passed. Media constantly reported, showed photos, debris pieces, Challenger's wing, engine parts, but no cabin. March 7th, 1986, 6 weeks after the explosion, the cabin was found. On the ocean floor, 100 feet deep, heavily damaged. But there, divers looked inside, 7 bodies, all were there, recovered, returned to families, funeral services were held, 7 different ceremonies, 7 different cities. The nation mourned. President Reagan addressed the nation, spoke on television, words were emotional. Today we mourn, we've lost 7 heroes. But they didn't die in vain. They were pioneers, explorers. They were brave. And the future belongs to the brave like them. We will never forget them. This morning when we last saw them, preparing, smiling, waving, and now they have slipped the surly bonds of earth and touched the face of God. Beautiful words, but didn't ease the pain for families. 7 people were gone, they weren't coming back. The Rogers Commission was formed, chaired by William Rogers, former Secretary of State, mission. Find out what went wrong. Other important people were also on the commission. Neil Armstrong, first person to walk on the moon. Sally Ride, first American woman in space, and Richard Feynman. Feynman was special, physicist, Nobel laureate, had worked on the Manhattan Project, building the atomic bomb. He was brilliant, curious, had no respect for authority, wasn't afraid to ask questions. The commission began working, thousands of pages of documents reviewed, hundreds of people interviewed. Debris pieces analyzed, and slowly the truth emerged. The bottom O-ring of the right solid rocket booster had failed. Due to cold weather, hot gas had leaked, damaged the fuel tank. Tank exploded. That was the technical reason. But there was a deeper reason: management failure. Feynman attended the commission hearings. NASA managers spoke. Everything was according to procedures, they said. Risk was at acceptable levels. Feynman listened, but didn't believe it. He met with Morton Thiokol engineers. Privately. They told the truth, that they'd warned, that they weren't listened to. Feynman decided to do something, simple, effective, something everyone would understand. February 6, 1986. A Rogers Commission public hearing. Being broadcast live on television, Feynman sat there. In his hand, he had a small O-ring piece. He'd gotten it from NASA. In front of him was a glass of ice water. During the session, while talks continued, Feynman took the O-ring, put it in ice water, waited a few minutes, then took out the O-ring, showed it to commission members. Cameras shot close up. "Look," said Feynman, "this is an O-ring. Stayed in ice water a few minutes. Now it's stiff, lost its elasticity. If you compress it," he compressed it, "it doesn't return to shape, stiff. Rubber becomes like this in cold." A simple experiment, but powerful. Everyone understood. On the morning of January 28th, said Feynman, the O-rings were below freezing, maybe -10 degrees. Rubber stiffened, didn't seal properly. Hot gas leaked. Result: catastrophe. The room was silent. NASA managers weren't comfortable. Feynman continued. Engineers knew this, they warned. But management didn't listen. Why? Because schedule was important, politics were important, image was important. The commission report was published months later. Conclusion: technical reason, O-ring failure due to cold weather. Deeper reason: management failure. NASA put schedule ahead of safety, ignored engineers' warnings. Morton Thiokol management silenced their engineers. The disaster was preventable if they'd listened, if they'd decided to postpone one day, if they'd waited for the weather to warm. But they didn't wait, and 7 people died. From 1986 to 2026, 40 years passed. Every year on January 28th, NASA holds Day of Remembrance to remember all lost astronauts, Challenger, Columbia, Apollo 1. Ceremony at Kennedy Space Center. Families come, former NASA employees come. Flowers are laid, names are read, silence observed. Christa McAuliffe became a symbol of civilian access to space. Many schools bear her name. Scholarships given in her name. Planetariums bear her name. Teacher in space program eventually returned, but with a different name. Educator astronaut program. Teachers trained as astronauts. Barbara Morgan, Christa's backup, finally went to space in 2007. 21 years later, flew for Christa. Bob Ebeling, the warning engineer, felt guilt for 30 years. Every January 28th he'd cry. I should have done more, he'd say. I couldn't stop them. 7 people died, and I knew. In 2016, 30 years later, NPR radio interviewed him. He told his story. The world heard, and people wrote to him. Thousands of letters, emails. You're not guilty, they said. You did everything you could. You warned. They didn't listen. The fault is theirs. Did Bob find peace? Not completely. But some. That same year he died, 2016, at 90, after carrying the burden for 30 years. Roger Boisjoly, the other warning engineer, had testified at the Rogers Commission. Told the truth. But then was ostracized by the industry. Couldn't find work. Nobody wanted to hire him. Branded with the whistleblower label. But he didn't give up. Became a safety advocate. Gave talks at universities. Told engineering students. Ethics always comes before company pressure, he said. If something is wrong, you must speak up, whatever the consequences. He died in 2012 at 73. But his legacy lives on, taught as an example in engineering ethics courses. The modern space age looks different. NASA isn't the only player anymore. There's SpaceX, there's Blue Origin, there's Virgin Galactic. Private companies going to space, and civilians really going. Rich tourists going to the space station, going to the moon soon. But Challenger's lesson isn't forgotten. Space is still dangerous. Rockets are still dangerous. Every launch is a risk. Must be careful. Engineers must be listened to. Safety must come first. 73 seconds, 7 lives, 40 years later, still remembered, still teaching, still warning.